Hello and welcome back to BlueHat CyberSec Academy. In this video, we will explore further topics from Domain 4 of the Certified in Cybersecurity exam, which is about network security concepts. This video isn't just for exam preparation, it's also perfect for anyone interested in building a strong foundation in the world of cybersecurity. In this lesson, we would explain IP addressing, both IPv4 and IPv6, Wi-Fi technology, and the critical role of ports and protocols in networking. We would also discuss the importance of securing ports to prevent vulnerabilities. So, let's begin. Internet Protocol, both IPv4 and IPv6, is currently deployed and used worldwide in two major versions. IPv4 provides a 32-bit address space, which by the late 1980s was projected to be exhausted. IPv6 was introduced in December 1995 and provides a 128-bit address space along with several other important features. Now, let's continue by looking at how IP addressing works in practice. IP hosts and devices associate an address with a unique logical identifier. An IPv4 address is expressed as 4 octets, separated by a dot. For example, 216.12.146.140. Each octet may have a value between 0 and 255. However, 0 refers to the network itself, not a device on that network, and 255 is generally reserved for broadcast purposes. Each address is subdivided into two parts, the network number and the host. The network number, assigned by an external organization such as the Internet Corporation for Assigned Names and Numbers, or ICANN, represents the organization's network, while the host portion represents the network interface within that network. To ease network administration, networks are typically divided into subnets. Because subnets cannot be distinguished with the basic addressing scheme discussed so far, a separate mechanism, the subnet mask, is used to define the part of the address assigned to the subnet. The mask is usually converted to decimal notation, such as 255.255.255.0. Moving forward, with the ever-increasing number of computers and network devices, it became clear that IPv4 does not provide enough addresses for our needs. To overcome this shortcoming, IPv4 was subdivided into public and private address ranges. Public addresses are limited, but this issue was partially addressed with private addressing. Private addresses can be shared by anyone, and it is highly likely that everyone on your street is using the same address scheme. The nature of the IPv4 addressing scheme meant that network designers had to begin thinking in terms of IP address reuse. IPv4 facilitated this through the creation of private address groups. This allows every LAN in a small office or home office environment to use addresses such as 192.168.2.x66 for internal networks, without fear that another system could intercept traffic on their LAN. Next, the first octet of 127 is reserved for a computer's loopback address. Usually, the address 127.0.0.1 is used. The loopback address provides a mechanism for self-diagnosis and troubleshooting at the machine level. This enables a network administrator to treat a local machine as if it were a remote one and ping the network interface to determine whether it is operational. Now let's move on to IPv6. IPv6 is a modernization of IPv4 and addresses several weaknesses in the IPv4 environment. A much larger address field, IPv6 addresses are 128 bits, which supports 2 to the power of 128, or 340 undecillion hosts. This ensures we will not run out of addresses. Improved security. IPsec is optional in IPv4 networks, but mandatory in IPv6, helping ensure the integrity and confidentiality of IP packets while allowing communicating partners to authenticate each other. Improved quality of service, or QoS. This helps services obtain an appropriate share of a network's bandwidth. Now let's move on to the next topic. What is Wi-Fi? Wireless networking is a popular method of connecting corporate and home systems because of its ease of deployment and relatively low cost. It has made networking more versatile than ever before. Workstations and portable systems are no longer tied to a cable, but can roam freely within the signal range of deployed wireless access points. However, with this freedom comes additional vulnerabilities. Wi-Fi range is generally wide enough for most homes or small offices, and range extenders may be placed strategically to expand coverage for larger campuses or homes. Over time, the Wi-Fi standard has evolved, with each updated version becoming faster than the last. In a LAN, threat actors must physically enter the space or immediate vicinity of the physical media. For wired networks, this may involve placing sniffer taps onto cables, plugging in USB devices, or using other tools that require physical access. By contrast, wireless intrusions can occur at a distance. Now let's continue toward understanding how these vulnerabilities fit into the broader topic of network security. Security of the network is, honestly, a pretty big concern these days. TCP/IP's vulnerabilities are numerous. Improperly implemented TCP/IP stacks in various operating systems are susceptible to denial of service and distributed denial of service attacks, fragment attacks, oversized packet attacks, spoofing attacks, and man-in-the-middle attacks. TCP/IP, like most protocols, is also subject to passive attacks via monitoring or sniffing. Network monitoring, or sniffing, is the act of observing traffic patterns to obtain information about a network. Now, let's move forward and explore ports and protocols, which play a major role in both communication and security. So, when we talk about ports and protocols, we're really talking about how applications and services communicate. There are physical ports that you connect wires to, and logical ports that determine where data and traffic go. Physical ports are found on routers, switches, servers, computers, and other devices. These are the ports into which you connect wires, such as fiber optic cables or Cat5 cables, to create a network. When a communication connection is established between two systems, it is done using ports. A logical port, also called a socket, is an address number that both ends of the communication link agree to use when transferring data. Ports allow a single IP address to support multiple simultaneous communications, each using a different port number. In the application layer of the TCP/IP model, which includes the session, presentation, and application layers of the OSI model, numerous application-specific or service-specific protocols exist. Data types are mapped using port numbers associated with these services. For example, web traffic, or HTTP, uses port 80. Secure web traffic, or HTTPS, uses port 443. Some services may have two ports assigned, one secure and one non-secure. Now let's discuss secure and insecure ports in more detail. Some network protocols transmit information in clear text, meaning the data is not encrypted, and, honestly, should not be used in modern secure environments. Clear text information is vulnerable to network sniffing. This method uses software to inspect packets as they travel across the network and extract text such as usernames and passwords. Network sniffing can also reveal the contents of documents and files sent through insecure protocols. Now let's review several insecure protocols along with their recommended secure alternatives. Port 21, FTP, File Transfer Protocol, sends usernames and passwords in plain text between client and server. This data could be intercepted by an attacker and used to retrieve confidential information. The secure alternative is SFTP on port 22, which uses encryption to protect user credentials and data packets. Port 23. Telnet. Telnet is used by many Linux and other systems as a basic text-based terminal. All information on a Telnet connection, including usernames, passwords, and on-screen text, is sent in plain text and can be intercepted. The secure alternative is SSH on port 22, which encrypts all traffic. Port 25, SMTP. Simple Mail Transfer Protocol on port 25 is the default unencrypted method for sending email. Data inside emails can be captured via sniffing. A secure alternative is SMTP over TLS on port 587, which encrypts communication between mail client and server. Port 37. Time Protocol. This legacy protocol has mostly been replaced by NTP on port 123, which offers better error handling and reduces unexpected issues. Port 53. DNS. DNS remains widely used, but its data can be intercepted or modified. DNS over TLS or DOT on port 853 protects DNS information in transit. Port 80. HTTP. HTTP is used for most basic web traffic, but sends information unencrypted. HTTPS, using TLS encryption, protects data in transit between browser and server. SSL is no longer considered secure. TLS 1.3 or higher is recommended. Port 143. IMAP. IMAP on port 143 is unencrypted and vulnerable to sniffing. The secure alternative is IMAP over SSL, or TLS on port 993, which encrypts messages between client and server. Ports 161 and 162. SNMP. Simple Network Management Protocol is used for managing infrastructure devices. Because sensitive data may be included, it is recommended to use SNMP version 2 or SNMP version 3, which offer encryption and enhanced security. All versions use the same ports, so context is required to determine security. Port 445, SMB. Server message block is used in many Windows environments for file sharing, but sends files unencrypted and is associated with many vulnerabilities. Traffic on port 445 should not pass through a firewall at the network perimeter. A more secure alternative is NFS on port 2049, although it too is generally not recommended through firewalls. Port 389, LDAP. Lightweight Directory Access Protocol communicates directory information, such as email addresses or login names. Because it is unencrypted, it is susceptible to sniffing and manipulation. LDAPs, which adds SSL or TLS encryption, protects this information while in transit. That's all for now. Thanks for tuning in. Keep the momentum going by checking out the next video in the series. If you haven't already, please like, share, and subscribe to BlueHat CyberSec Academy.